Hi, Jude. Um, Here are some examples for what we're doing today. Okay, I wanted to just um, kind of focus on a few things here. First of all, let's go with, actually, I don't want to, I'm going to use, yeah, let's just say we have y equals 2 to the x power. Okay, now when you graph, let's just say you graph something like this, an exponential function. Okay, let's say I use x and it's 1, 2, and 3. Okay, so if I plug in 1, 2, and 3 for x, that's pretty straightforward, right? 2 to the first power is 2, so y is equal to 2. 2 squared is 4. So again, I'm just plugging in these numbers in for the, I'm plugging in for the exponent here, so that'll be 8. Okay, but now let's check out the 0, and then let's check out the negative numbers. If I plug in 0, right, y is equal to 2 to the 0 power, and anything to the 0 power is equal to 1. Okay, what if I get negative 1? Y is equal to 2 to the negative 1 power. A lot of people say it's negative 2, and that's a really common mistake. But remember that when you do an exponent, when you do a negative exponent, there's nothing negative about it. I always say that. So it's 2 to the first power, and so that equals 1/2. Okay, and then negative 2, so y is equal to 2 to the negative 2 power. That equals 1 over 2 squared, and that's equal to 1 over 4. Okay. So notice that when I graph something like this, don't pay attention to this, but when I graph something like this, okay, so 1, 2 is right here, right? 2, 4 is right here. 3, 8 is right here. And then 0, 1 is right here. And then as you go along, it's gonna look something like this, where it's almost hovering along the x-axis, but not quite. And it's shooting up after that. Okay, and so this line right here, it gets closer and closer to the x-axis, but it doesn't quite hit it. Okay, so now they ask, what is the domain? Not give the, yeah, so give the domain. Remember, the domain are all the possible x values. Okay, and notice that the graph continues to move on this way and this way. And looking at the arrows left and right, notice that the domain in this case is all real numbers. Okay. Again, the domain is all the possible x values. So if the domain's all the possible x values, the range is all the possible y values. But notice this, look at this graph right here, and notice that it doesn't cross, it's never going to cross the x-axis, right? So if the graph's not going to hit this portion right here, this bottom part, okay? So notice that it stops at 0. So the range is everything above the x-axis. So the range is all real numbers greater than 0. Okay? And then the question asks you, what are the x and y intercepts? Well, again, the x-intercept is where the graph hits the x-axis. The y-intercept is where the graph hits the y-axis, right? And so notice that this line right here, although it's really close to the x-axis, it doesn't quite touch it. So there is no x-axis, or sorry, x-intercept. And for the y-intercept, notice that it hits it at 1, at 0, 1. What you have to do is you have to make, if you want to find the y-intercept, you have to make the x equal to 0. And that's what this is right here. And so the y-intercept is 1. Okay. All right. Now let's look at the Desmos calculator. I'm going to shift gears here, right? And I'm going to go to the other screen. Let me see, is it this one? No, not this one. It's right here. Let's go to the Desmos calculator here. Okay, and I want to show you what the different numbers do to a graph. Okay, so remember this thing called the parent function. The parent function is the main function. It's basing everything from. So let's look at our y equals 2 to the x power. So you put caret, and that's the x power. So this is the graph that we just did. okay? Now notice from this graph here, let's say I put a y equals 2 to the, and then let's say I put a number inside of the exponent, so like x minus 3. What does the minus 3 do? Notice that if the number, or like this number 3 is within the exponent, it's going to shift left, it's going to shift this horizontally, left or right. Okay, all right, okay. And then if so since it's minus 3, it's going to do the opposite. Okay, so this is the red, this is the original graph. Notice that even though it's minus, it's going to the right 3. Okay, so vice versa, if I wanted to go y equals 2 to the x power, x plus 3 power, it's going to go 3 to the left. Okay, so you have, when it's inside the exponent, okay, you have to do the opposite sign. You have to shift the opposite way. Whereas x minus 3 goes to the right, x plus 3 goes to the left. Okay. Now, what if the minus 3 was outside here? Notice what it does to the original graph. It goes down 3, right? And if I wanted to go up 3, y equals 2 to the x power, it goes up 3. So these signs are true to what you see right here. So if you see a minus 3 outside of the exponent after the parent function, right, then it's going to go its true direction. It's going to go down 3 or up 3. Okay, if you see a plus, it's going to go up. If you see a minus, it's going to go down. Okay, now let me ask you this. Let's check this out. If I put let's say if I put a 1/2 in front of the parent function here, oops, what does it do? Okay, it does we're checking the blue. We're comparing the red to the blue. Okay, and so you notice that it kind of leans. It's less steep, right? It's a little bit steeper. So what the fraction does, they call this a vertical shrink. Okay, if you're affecting the base, if you're multiplying the number to the base itself, pretty much, you're gonna affect it vertically. If you're gonna put the number inside the exponent, it's gonna affect it horizontally. Okay. Now let's look at this here. If I go y equals, let's say 3, and if I multiply that by the parent function, notice that it becomes steeper, right? And so that is a vertical stretch. Okay. So if the number is greater than 1 in front, it's going to be it's going to be a stretch. Okay. If it's going to be a fraction, okay, it's going to be a shrink. All right. That's pretty much it. So again, if the number's less than 1, it's going to be a shrink. If the number is greater than 1, it's going to be a stretch. Okay. All right. So let me add one more thing. People could go crazy with this. If I have 2 and then, oops, x minus 2, x minus 2, and then I put a plus 4 or plus 5, what this does is it shifts the red graph over 2 times to the right, and then it goes up 5 times. Okay, so that's what you're doing here with each of these parts. Okay, all right. So I'm hoping that this would help. So let's go back to the worksheet here. Okay, so that should answer your questions here. So now be careful here, because like number 4, notice that it goes down 3. So if the graph goes down 3, let me annotate this. The graph goes down 3 here, 1, 2, 3, right? And then it does something like this, right? Well, you have a new asymptote, right? The asymptote will be this line right here, right? Which is y equals 1, 2, 3, -3, right? The x-intercept is up here, right? Somewhere, let's say like 2, and the y-intercept would be, the y-intercept would be at -2. Okay, so, and so again, things change as you shift these numbers. Okay, again, I suggest you graph these numbers on the Desmos calculator. Okay, now let's look at number, these 5, 6, 7. What are these numbers? What does a negative do to the parent function? What does the 2 do to the parent function? What does this plus do to the parent function? What does this -3 plus 2 do to the parent function? You have to describe what it's going to do. Okay, all right. And then you're going to have to answer these questions like for any graph. Okay, and so again, what you should do is just graph this on, once you understand how to graph the parent function, graph it on the Desmos calculator and see the differences, and then answer the best you can. All right, have a good night. I'll see you later. Bye.